Well, hi there, boys and girls. Today we're going to talk about the average value of a continuous function, and I also want you to write something else for me here in your notes. I also want you to write height. I want you to think about average value along with average height. So let's take a look at what this says. We've got a mean value theorem for integrals that says if f is continuous on a closed interval a to b, then there's some number c in the closed interval a to b such that the integral matches f of c times b minus a. And this big paragraph here is very important about what this means. We know that our integral from a to b of f of x dx is the net signed area underneath the curve. F of c is a height at some value c, and b minus a, that is a width. What we are saying here geometrically is that we can turn any curve, as long as it's continuous, into a rectangle. And there's this miraculous, perfect little place, some c value in between a and b, where we can go up to the curve, make a rectangle, and that rectangle would have the exact same area as the what's underneath our previous curve. So that's what all of this height says. So let me see if I can draw you a little graph what this means geometrically. So I'm going to have a to b, and I'm going to have f of x do something like this. I don't know, something like that from a to b. What this is saying is that there's some c value in here where you can go up to the curve and make a rectangle across the interval from a to b, and the area of that rectangle would have the exact same area as what's underneath this curve. So somewhere in here there is some place to draw, go up to the curve, and have a rectangle that has that. We're going to call that the perfect rectangle, and that's going to happen at the average height of the graph. So somewhere along here there's this magical line that can be the height of our rectangle, and this is going to be the average height. And I would guess it would probably be somewhere in here. I would call that C. So if I were to go up there to C and make a rectangle with that height, that rectangle would have the same area as all of this stuff in here. That's what the mean value theorem for integrals says. Now, because this is a theorem, it's true, which means we can rewrite this and we can actually find the average height or the average value by dividing by b minus a. And probably one of the most used applications of this, if you ever want to find like average speed when you're looking at a speed graph, or if you want to find the average value of a stock, if you're looking at the price of that stock's graph, you find the area under the curve and you divide it by the width, and that will give you the average height. And so that's what this formula is right here. The average height, or the average value of a function, is the area under the curve divided by the width. So let's take a look at some examples here. I got a function 1 plus x squared, and I'm supposed to find the average value of f on the given interval. So I'm going to do my little formula. My average value of f is going to equal 1 over b minus a, 2 minus negative 1 is 3, times the integral from negative 1 to 2 of f of x dx. That's just my formula. The integral gives me the area, dividing by the width will give me the average height, or the average value. And so I'm just going to go do this without a calculator. We're going to find an antiderivative first, bx plus x cubed over 3. We're going to evaluate this from negative 1 to 2. So I'm going to have 1/3 times 2 plus 8/3. And then that's plugging our 2. And now we plug in our negative 1. Running out of space. Negative 1 minus 1/3. So that's going to equal 1/3 times. Well, 2 is 6/3. 6/3 plus 8/3 is 14/3. And then this would be a negative 4/3, but the two negatives make a positive, so plus 4/3. So I'm going to have 1/3 times 18/3, which is 18/9, which is 2. What we are saying is that the average height of 1 plus x squared from negative 1 to 2 is 2. The next part says find c such that the average value of the function is equal to f of c. So we want to figure out when does 2, the average value of function, equal f of c. So I'm going to have 1 plus c squared. F of c is just plugging in c for x. Subtract 1 from both sides. Square root, c equals plus or minus 1. Now in our theorem we wanted c to be in between a and b, and a and b here are negative 1 to 2. So I'm going to say that that happens about at 1. And geometrically, let's go figure out what we've said. F of x is 1 plus x squared from negative 1 to 2 looks something like this. So we'll quadratic from -1 out here to 2. Now what we have said, and by the way, the y value of -1 is 2, and the y value out here at 2 is 5. Now can you believe that right here would be the average height of that graph? Now, I can believe it. There's some below it, there's some above it. That looks about to be the average height of that graph. And what we have said is that this value C1 is where that graph out here at 1, that's where that graph intersects the line y equals 2. So that's where we would make our rectangle, and the area of that rectangle would match the area under the curve. So let's take a look at combining Riemann sums with this. So I've got a table of values, and I'm supposed to find a left Riemann sum with 3 subintervals to estimate the average value of f on 5 to 17. So I want to find the average height. Before we do this, why don't you estimate it? This is the graph of f. What do you think the average value is? Now we can't just add those up and divide by 4, but I'm thinking it's probably, I don't know, I haven't worked this problem yet. It goes 23, 29, 36, back down to 27, 29-ish, 30-ish, 28-ish, I don't know. Let's use our formula and estimate it with the left Riemann sum. The average value would be 1 over b minus a times the integral from 5 to 17 of f of x dx. Now since I don't have a function that is defined by an explicit equation, I've got to use a Riemann sum to approximate it. So my Riemann sum is going to be an approximation, and we want left Riemann sum. So our first interval is from 5 to 9. That has a width of 4, and our height comes from the left-hand endpoint, 4 times 23. Plus our next interval is from 9 to 12. That has a width of 3 and a height of 29. We use the left-hand sum. And then on my next interval is from 12 to 17. That has a width of 5 and a height of, well, it looks like that height is 36 because I have to use my left-hand endpoint. All right, so I did this on the calculator just now, and I got that this value was 29.9167. And I guess I can believe that that would be probably about the average height. Okay, so let's look at another example here. Studies suggest between the hours of 1 and 4 on a normal weekday, the speed of the traffic on a certain freeway exit is modeled by this formula. So this is the speed formula. And we're measured in kilometers per hour. T is the number of hours past noon. So we want to compute the average speed of the traffic between the hours of 1 and 4. So I want to find the average height of this graph between 1 and 4. So I'm going to do my formula 1 over 4 minus 1 over b minus a, times the integral from 1 to 4 of s of t dt. So the average height would be, that equals the average value, and we're supposed to use our calculator for this. So I have one of those down here. Let's drag it over here. So I want to do 1 over 3, well, not answer 1 over 3, 1 divided by 3, and I want to do times the integral of 2x, we can use x's instead of t's, no problem, 2x cubed minus 21x squared plus 60x, I hope you guys are faster than me at typing this in, plus 20. And we would do comma x, and we're looking from 1 to 4. So comma 1, comma 4. Close parentheses and hit enter. And so that's 131 over 2. Should be 65.5, and it is. So we've got 65.5 is the average speed. So that's 65.5, and this is measured in kilometers per hour. Alright, well, I'm not going to do another Riemann sum with average value because we just did one. We don't need another example of that. But I do want to show you a way of doing it geometrically and getting the exact answer. Let's take a look at our piecewise function. I've got 3 minus x from negative 1 out to 3. So here's 3 and here's negative 1. And 3 minus x has a y-intercept of 3, and it has a slope of down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So that's going to make just, of course, that's just a straight line. Even though I'm not drawing it perfectly straight, that's a straight line. And so that makes a nice little triangle. And then from 3 to 6, which is right there, we are the graph of 2x minus 6, which is up 1 over 1, up 1 over 1. And I can plug in 6, up 2 over 1, up 2 over 1, up 2 over 1. I do know what slope means. If we plug in 6 to this equation, we're going to get 2 times 6 is 12 minus 6 is 6. 1, 2, 3, 4, 5, 6. So I'm up here about right there. So up 2 over 1, up 2 over 1, and up 2 over 1. And I try and do a straight line graph. All right, so we want to find the average value of this function without integrating. We want to actually figure out what it is. So it's going to be some average height in here. You could probably estimate it. So what we're going to do is set up the integral. The average value would be 1 over 6 minus negative 1. We're just not going to use the integral to do it. 1 over b minus a times the integral from negative 1 to 6 of f of x dx. We do the area under the curve divided by the width. That will give you the average height. So we're going to do this without integrating. We are going to use the fact that the integral would be the net signed area under the curve, which would just be the combined areas of these two triangles. So I've got this first triangle. I've got a height of 1, 2, 3, 4, and a base of 4. So 4 times 4 is 16 divided by 2 is 8. That has an area of 8. And my second triangle, I've got a base of 3 and a height of 6. 3 times 6 is 18 divided by 2 is 9. And so it's going to be 17 over 7. And that's about 2.4-ish, something like that. It's 2 with the 3/7 remainder, so 2.42. So bigger than 2 but less than 3. So can you believe that right here, that would be the average height of that graph? I can. That looks pretty much in the middle to me. So anyway, that's what you'll be calculating tomorrow is average value, and I will see you guys then.